Section 1.5, Intermediate Value Theorem. How do we define and use the intermediate value theorems? So you'll find that these sections in particular, you're using a lot of statement, you're using a lot of logical reasonings instead of math calculations. So it's more like a concept problems rather than the actually solving a math problems. So first, let's see what is intermediate value theorem. And again, you will see that it's kind of intuitive for you to answer the questions rather than going through these math steps. But think about what you did in geometry. You still have to prove it. You cannot just say, oh, because I feel like it is the way it is, so it's going to be the result. You have to show the reasonings. Okay, so what's intermediate value theorem? Intermediate value theorem states that f of x is continuous. So first, you have to show that the function is continuous between the a and b. So between a certain value, a and b, the function is continuous. And m is a value that between f of a and f of b. Then according to intermediate theorem, there is C such that f of C is going to equal to m. So if I give you a visual representation, it will be something like this. You have a function, and here's your a value, f of a. So this is my a value, and then I have another b value here, which is, so that indicates my f of b. And then a value between, so you have a value in between a and b, which is f of a, and f of b, which is m. You will find that it's going to be f of c, a value c, that the x value is c. So it's in between, intermediate. So what are the steps you should take to prove that the function does have the values c f of c equals m? So of course, you have to know that since I gave you the very first statement, show that the function is continuous. And remember what we talk about continuous functions, you have to refer back to previous sections. So your limit would have to exist, and then the function value is the same as your limit values. And then you're going to find the second step, you're going to find f of a and f of b. And then third step, show m is between f of a and f of b. And the last step, you're going to make the statement. Using the quoting, basically you are quoting the intermediate value theorem. Intermediate value theorem. So I'm going to use the shorthand IVT, intermediate value theorem. Here you will find some of the symbols as you read your notes, as you read your textbook. This looks like I've been using this when you're using the number set. It's actually called the belongs to, but you can say that sometimes it's called as the element of, belongs to, or you can say as element of. But if you have like a capital letter E reversed, it's pronounced as there exists. And the next one is ST. What does ST stands for? It's such that. So these are just some shorthand. And the last one is like a V, upside down A. So it stands for every. So these are some shorthand words that symbols you're going to see for these particular sections. Now let's take a look at the examples here. We know that the function is going to be continuous. Show that. F of x equals x squared takes on the value 0.5 somewhere in the interval between 0 and 1. So if between x equals 0, x equals 1, the function will have a value of 0.5. So do you remember what's our first step? So I'm just going to go through these steps here. First one is, I need to say that this function is continuous between f of 0 and f of 1, right? So that's our very first step. It has to be continuous, otherwise we won't be able to do that. And since f of x equals x squared, it's a polynomial. It's not like a step function, nothing. So it's continuous. For all x. Well, for this, I can actually write it like this. Okay, so that's just a shorthand. I'm just showing you the symbol there. And what's our second step? Second step is going to find the f of a and f of b. So I'm just going to plug it in. F of a. So since we're going to look at the value of f of 0, 0 squared is 0. And then I'm going to plug it in b. F of 1 is 1 squared is 1. And then what's our third step? What's our next step? Third step is show that m is a value between f of 0 and f of 1. So since 0.5 is 0.5 between 0.5 between 0 and 1. Of course it is, right? So I'm just stating it because 0.5 is between the f of 0, which is 0, f of 1, which is 1. Okay? Just in case if you don't know what I'm doing here from this step, I'm writing it as f of 0 is in between m and f of 1. And what's our next step? What's our last step? So since all this was done, then basically the very last step is, since f of x is continuous and we know that f of 0 is less than 0.5 less than f of 1 by the intermediate value theorem. There exists a value c belongs to 0 and 1 such that f of c would equal to 0.5. Well, you can use your calculator to find that value c. You can basically take the square root of 0.5 and then you will find that it's going to be in between 0 and 1. Okay, so that's an easy example, and as you can see, we're not actually doing any math. We are just proving it, so it's very much like we did in geometry. And as you can tell already, it's kind of intuitive. The function is continuous and the function is in between a certain value, so there must be a number in between that exists to show that it is going to be take on the value of the 0.5. So next one is f of x squared over x to the 7th power plus 1 takes on value takes on the value of 0.4. So how do you show that the function is continuous? Step 1, is the function continuous? So I'm going to let you think for take a second to think about it. Is it continuous? As long as the denominator doesn't equal to 0. If you don't have anything that makes the denominator equal to 0, that should be continuous, right? So the function is continuous. So we can say that f of x is continuous anywhere except that x cannot equal to -1. X to the -1, if x equal to the -1, -1 to the 7th power plus 1 will make the denominator equal to 0. So that's the only place that the function will not be, is not continuous. Step 2. So we have f of 0. So we're going to plug it in between 0 and c. 0 squared plus over 0 plus 1, which is 0. And then we're going to plug in f of 1 to see 1 over 1 plus 1, which is 1 over 2, which is 0.5. So it happens to be 0.5. Step 3, we see that f of 0 is going to be less than 0.4, and then f of 1. So 0.4 is going to be less than 0 and greater than 0 and less than 0.5 there. So what conclusion can you say? What conclusion can you say? Since the function f of x is continuous, between 0 and 1, and you know that f of 0 is less than 0.4, less than f of 1, by the intermediate value theorem, there should exist a value c such that it's in between 0 and 1, and it will have a value such that f of c is going to equal to 0.4. So, like I said, you will see that it's kind of lengthy and long descriptions of the concept, and it's kind of intuitive. So make sure you practice a few examples